Let's take a look at another CSES sorting problem, sum of two values. So what's going on here? We have some array of length n, and we want to find two values from the array whose sum is x. Distinct positions, right? They can't be the same element twice. Although they could be the same number twice if that number appeared twice in the array. Anyway, so we just given the array and the target value, and we should print the indexes of the values, one indexed. And if there's no solutions, print impossible, right? So in this example, we're trying to get 8, and we can get it from 7 and 1, which are positions 2 and 4. So let's do it. So we want to read in n and x, and we're going to read in the array. Okay. Yeah, maybe I should have talked about how we're going to do it. So as you might guess from the title of this section, this is we can do it with sorting. So we're going to sort the array, and then use the so-called two pointers technique. So the idea is you start from the smallest number in the array, and you try and see if it has a pair. And then, right, so you're going to start from both ends of the array. Smallest number, see if it pairs with the largest number. If that sum is too big, then you need to bring the largest number down. If that sum is too small, then you can move forward to the next element. So the point is that if the pair, right, so here's our array, right, so we try to see what 1 could pair with to make, I don't know, 7, let's say, right? So 1 plus 12 is 13, which is too big, so we need to go down. 1 plus 10 is 11, which is too big, so we need to go down. Now 1 plus 4 is too small. Okay, so we know that 1 isn't going to work, right? Because we passed from too big to too small without ever hitting anything. We know everything down here is smaller than 4. So now we can go up to 2. So what can we match 2 with? So the key idea here is that we don't need to check match 2 against 12, because we already failed to match 1 against 12, and we know that 2 is bigger, right? It's the next element of the array. And so in fact, when we're matching 2, we can just pick up where we left off, right? We don't need to check 10 either, because we know that was already too big with the smaller number. So we can check 2 and 4, right? Because 4 was too small, but 2 is bigger, so it might be big enough. 2 and 4 is also too small, so now we go to 3. Now we can check 3 and 4, and 3 and 4 actually works. But if we wanted to make like 8 instead, then 3 and 4 wouldn't work. And then we could check 3 and 3, and that's actually illegal because those are the same position in the array, and then we could realize, we're done. Right, they've like crossed. You could actually just keep going if you wanted, but I don't know, you can also stop there. So let me actually code that up. So sort A. Right, so we're going to go through all of the numbers. Right, and so this is the thing we're trying to pair with. So if ai plus an is greater than x, right, so this is actually almost what we talked about. Right, so while the sum is too big, decrease end. If you find a match, then print out that the answer and return. And otherwise, you just keep going through the the next element of the array. But there is a problem here, and the problem is that we need to check if I is equal to end here. So you can do that, right? Because we're not allowed to use the same element twice. Otherwise, you might use, if ai is half of x, then you might think that ai plus ai equals x, but that's not allowed. Have to be distinct elements. And that should be it, actually. So we can do includes, We need IO scheme for IO, vector because we're using this vector, algorithm is for sort, and we also need namespace std and long. Compiles, excellent. One and four. That would seem to be wrong, actually. Oh, I see. Yeah, okay. So this is saying that 1 plus 7 is 8 because we sorted them. So the positions changed, but we actually need the original positions. So we will just keep track of a pair. Utility is for pair, which is the position and the number. And we might as well just one index since that's what we need anyway. Checking if these indices are the same is the same as checking if these indices are the same. I guess it's a bit clearer to do it this way. But it's the same thing. It was already right before. Now it doesn't compile. So we're using X for the target and for this thing. You give it a default value, the right type. Okay. 4, 2, 2, 4, probably fine. Oh yeah, and if we didn't find anything, then print out impossible. Cool. All right, let's see if that's right. Wrong answer. We output 2 and 65. Well, that certainly does not seem right. Yeah. Let's make sure we're right about this case. Impossible now. Okay. So the issue there was that we allowed end to roll over to -1 when we should have stopped it at 0. Okay, and now it's correct. Yeah, so it is kind of annoying to have to deal with the indices here. So that's, I don't know, it's just kind of a pain. But because we're going to sort them, we need to store the original index. So we write that down along with the value, then we sort them. Then we do the 2 pointers trick. And because we're not allowed to use the same index twice, we have to do this kind of annoying thing. It's a little harder to think about whether or not this is right or not, I think. But anyway, the key of the 2 pointers trick is this, which is that you just keep track of one ending index, and you reuse it for all of the starting indexes. Right? Sort of a naive solution would be to loop through for I and then for j is the second thing. Right? This is sort of like the second for loop. But we're only doing the second for loop once over the whole run of the program, because we know that whatever, if a small value in this thing is too big, then a bigger value in that thing is also going to be too big. So we only need to check each element once. Right? Once an element is too big for a smaller value, it's also going to be too big for a larger value. And that's the point of sorting, is that we can go through the values from small to large and from large to small, and that actually lets us reuse that work. So if we find something, we print it out, and then we return, so we don't do any, we don't want to print out like double answers or anything. And if we don't find anything, then we just print impossible, right? And this code only runs if we never got to return here. We never print out an answer before. So that's the problem.